All right, hey Owen. We are doing the second half of 2-1. We got like 3 homework problems left, I think, if you did all the ones from yesterday, but these are all the applications, okay? This is applications of quadratic functions. We got to talk really quick about discriminant, okay? I'm going to talk just briefly about discriminant. When we do the quadratic formula, negative b plus minus the square root of b squared minus 4ac all over 2a, okay? This guy is really important in the fact that, like, there's pieces that you use from it to find other things, okay? Like yesterday we talked about how if you have something that is like in standard form, like x squared plus 4x plus 5 or whatever, we can use the negative b over 2a method, right, to find what?
Something.
What does he find?
The x-coordinate of your vertex.
Yeah, he finds the x-coordinate of your vertex. So we plug him in, right, to find the y and doing all that stuff. That comes from the quadratic formula. All right. Now, we've talked about this earlier in the year, b squared minus 4ac. What is that thing called?
The discriminant.
That's the discriminant, okay? Now, if that number inside of there is negative, for example, I'm going to go down here on the very bottom. If I have 4 plus minus the square root of negative 4 all over 2, like in this bottom one, okay, this is telling me the zeros. The zeros are equal to that. What's a zero mean, by the way?
The spots where it hits the
Like an x-intercept or like a zero or a root or a solution, whatever, right? Okay, the fact that there's a negative inside of a square root or that number is less than 0 means that there is no solutions, no x-intercepts, no solutions. Okay, now, if that number is greater than 0, so I'm just going to flip this around and say like 4 plus minus the square root of 4 all over 2, right? He is going to have, like that number is bigger than 0, right? 4 is bigger than 0. The discriminant is 4, right? What was the discriminant in this bottom one? What was the discriminant there? Negative 4. You're only looking at that number, right? Negative 4 versus this one is positive 4. He will have how many solutions?
Isn't this just like saying that if your thing is going downward and your vertex is negative, then it's automatically not gonna, like, that's kind of the same.
Yeah, honestly. That's what b squared minus 4ac like kind of does, basically. Yep, so if he is positive, he will have 2 answers. So like, for example, the square root of 4 is 2, so I would have 4 plus 2, which is 6 divided by 2. That would be 3 as a 0. And 4 minus 2 is 2 divided by 2, which is 1. So he would cross at 3 and at 1. That's 2 solutions, right? 2 x-intercepts. Yeah? Hi. Okay, if that number perchance is 0, I would have 4 plus and minus the square root of 0 all over 2, okay? Now, why is that only one solution?
Because it's equal to 0.
Because 4 plus 0 divided by 2 is going to be the same as 4 minus 0 divided by 2. They're exactly the same number, right? What is that number? 2, right? 4 plus 0 divided by 2 is 2. 4 minus 0 divided by 2 is also 2. So it only has one solution. So you can look at that discriminant part, and depending on what it has 1 solution, 2 solutions, no solution. Now, what does he look like if he only has one solution? Like it's a parabola, right? His vertex is touching, right? Like his bottom point, or it could be the other way around. It could be something that looks like this, right? Either bottom or top, something like that, right? Either the parabola is up or down, but the vertex is touching. If he has 2 solutions, he looks like this, right? Like where he's crossing and he has 2 places. If he has no solutions, he's like levitating, either up the top or below. What?
What did the original equation?
I didn't put an original equation. I just said, like, if this was our quadratic formula.
Like, usually if it's not moved up or down,
I'd be down.
vertex at 0.
Yeah, like if it's just x squared.
Or if it's x squared.
So, like, if it's just y equals x squared minus 4 or something like that, or not x squared minus 4,
Yeah, that would
x minus 4 squared,
Yeah.
that would only have one solution because he's only moved to the left 4, but he's still sitting on the x-axis, right? So he would only have one solution. Yeah. Yep. But if he has this, then he's gonna have
0 solution.
no solutions because he's up in the air, right, at 1. Okay, good. All right, example 4, here we go. A stone is thrown from a 100-meter cliff up in the air. That's our starting point, right? And it's going 20 meters per second at an angle of 30 degrees from the horizontal down. That's a lot of information, but you don't need it anyway because they give you the equation for this right here, okay? Negative 4.9 t squared plus 10t plus 100. That is the parabola that is happening. Okay, this is an up or down parabola. Which one?
It's a
Here's my cliff right here, right? And it's doing one of those. Whoop. It's a downwards parabola, okay? So you don't see this half of the parabola, right? Because that would be like on that side of the cliff, right? Okay? But there is that. Determine the time. So we're solving for t. At which, so t equals question mark, at which the stone will be at its maximum height. Oofda. What does that mean?
Vertex.
That means where is the vertex, right? Okay? But, and we're solving for time. So are we looking for the x coordinate of the vertex or the y coordinate of the vertex? X, because t is the x variable, right?
Right.
Okay? So we only have to, how do we find that t value? That x coordinate?
Zero for the y.
Nope, no. Well, yeah, you could plug 0.
Negative b over 2a.
Yeah, I want to do the negative b over 2a thing, right? Won't that give me the x coordinate of the vertex? Yeah? Let's do the negative. I'm going to do it down here. A, negative b over 2a. Okay, so what will negative b be?
Negative 10.
Negative 10 over 2 times negative 4.9. So I have negative 10 over negative 9.8. So a little over 1.
Yeah.
What is that?
1.
The two negatives cancel, right? 1 point, I don't know.
Probably 1.1.
Take 10 divided by 9.8. Somebody for me, would ya?
It's 1.02.
1.02. What does that mean?
Time at which
That's how long it will take for it to reach its.
Yeah, that's not very long, right? Because it's literally getting kicked up there, and it's like 1 second later, then it starts its descent, right?
1.
Because it doesn't have to go all the way up. It's already like basically up in the air. It takes 1.02 seconds before it reaches this highest point, okay? Part B, it says determine that maximum height, okay?
Now you plug in.
So now we're trying to find the y coordinate, right? So I'm going to plug that 1.02 seconds in here to find where it's actually at for the highest point. Does that make sense? Okay? So negative 4.9 times 1.02 squared, don't forget to square it, plus 10 times 1.02, okay, plus 100. And I don't know about you guys, but I try to do some stuff in my head if I can. So for example, like 10 times 1.02 is 10.2, but then I could do this in my head. That's 110.2, right?
Yeah. And then
So
the
it's
other
less to
side
type
is
in. What do you got?
point-
I got 105.1, but like
I got one. Did you add the 100?
Yes.
I got 115.
Both suck at math.
Nope, it shouldn't be 115. Because this is a negative 4.9.
Because
Yeah? Did you put a negative on the front of it?
Zach, let me do your.
Okay.
I did not.
110.2 should be highest. Like you're subtracting this guy from
I
there.
got what base.
Yep. 105.1.
only one of you suck.
105.1 is the height.
You should have been with us when we were doing.
What is that units in?
105.1
It was not.
meters.
Meters. Okay. Now, do we remember what the height was? Like where our cliff was?
100 meters.
100 meters. So it's only going up 5 meters. 5 meters.
15 feet.
Like till it gets to the highest point, right? Like it's literally getting like kicked up, you know, whatever, 5 meters up higher in the air. And it takes 1 second, it takes a little over 1 second to get to that maximum height of 5 meters above,
5
right?
meters.
I guess
Yeah.
5 meters is like 15 feet. Like that's a little bit high, right? Whatever. Okay, that was B. C, determine the time. Okay, so again, we're solving for time. That's the question mark. At which the stone will hit the ground. So what are we doing here?
An X. That's positive.
0.
We're solving for T,
You need to put it.
Oh, you're putting.
but we're putting
You're putting a 0.
0 in for Y. The height will be 0 when it hits the ground. So I'm solving for this. 0 equals negative 4.9 T squared plus 10 T plus 100. How do I do this? Nope, I don't want to subtract. I would subtract it. What? Plug it into what? Yeah. So this is a trinomial. We can't just subtract the 100 over because I have 2 t's there, right? Like that's not going to work. This is a trinomial, so we either have to either factor it, which we're not going to be able to with the 4.9 there, or plug it into the quadratic formula. So negative b plus minus square root b squared. Do you have this memorized?
Yeah.
Okay, you should. Negative b. We've already done this. Negative 10 plus minus the square root of what's b squared going to be? 10 squared, 100. Minus 4 times negative, don't forget that negative 4.9, times c is 100. All over 2 times negative 4.9. Okay. I need some help doing this. I know this is going to be some stuff. Like this is going to be a positive number plus something. Negative 10 plus and minus.
Yeah,
I don't know. Negative 9.8. I know that. What?
It's a number.
Somebody give me the number. I don't know what you're doing, Mace.
It has to be a positive number.
Mine said don't work no more.
It'll be okay.
It said put it under the thing.
What's the square root of 100?
4 times 4.9 is 20.19.6.
19.6.
You're right. 19.6 times 100 is 1960 plus another 100 is 2060. So this is the square root of 2060.
No, because you're subtracting.
No, because there's two negatives, so that makes it positive. I think that's maybe your problem.
Negative.
Okay, so here's what we want to do. We're going to do negative 10 plus the square root of 2060. We're going to find a decimal all over negative 9.8. And we're going to do negative 10 minus the square root of 2060 all over negative 9.8.
My negatives should cancel, right?
No, because they're trapped.
Well, that's
Not
the
a very good
positive
material,
one.
but it's fine.
Yeah, it's
Negative something. I think.
Oh, that's not right. Because. No.
It's like almost right fit.
So what it's doing right here, like this, is taking this answer, which was right on the top, and it's dividing by 2, and then it's taking that answer and multiplying by, so you want to do like a parenthesis around here.
How do I?
What size is this?
You might have to
This
just
is a
enter,
small.
I'm going to then
Bryce
divide it by
might drown in
negative
this.
9.8.
Bryce might drown in that small.
So negative 3.61
Those for those.
Is the positive?
is the positive one? Negative 3.61 is if I plus, right?
5.65.
What?
5.6.
Is this one? Is the 5.65? Okay, now here's what this means.
Ask us for our sizes.
He will be on the ground
But it's not going to be.
at negative 3.61 seconds, that's right here, which is before we even toss the rock or whatever, or at 5.65 seconds. So what's the true answer? 5.65, right? Because this is technically a parabolic function, we're going to have an answer over here, but that's not even existent because we're dealing with time. Yeah, so this is 5.65 seconds is where this is located, okay? But when it will hit the ground, you're going to plug 0 in for height, yeah? And then you're going to probably use the quadratic formula. Okay? Good?
Yeah.
All right. Example 5. I like this. Calculus. We're going to do a lot of these, and they're so much fun. The parking area is to be constructed, except we do it using derivatives. The parking area is to be constructed adjacent to the road, and the developer has purchased 350 feet of fencing. So 340. 340 has to deal with the what? Not the area. The perimeter. But we only need 3 sides, okay? Yeah. Determine the dimensions for the parking lot that would maximize the area. Okay, so we're looking at this guy, and how do we find the perimeter of that?
You add all the sides together.
Add all the sides together. So I would have 2x plus y equals how much? 340. Okay.
And we want them as close.
Determine the dimensions for, that would maximize the area.
Yeah.
Oh. Okay, so here's what we're doing. This is exactly what we do in calculus. Are you guys all listening?
We need a square.
This is a calculus problem right here, except we will do it using calculus, but setting this up is exactly the same. So this is for perimeter. When we're talking area, how would I find the area of this thing? X times y. So I want that to be a maximum, and I want the max to be equal to x times y. I want to maximize the area. So I'm just going to say max equals x times y. Okay, now I have 2 equations, and I want to.
By 3, and that's it.
Nope. Because when you only have 3 of them, it's not going to be necessarily as square as possible. If you're trying to minimize perimeter and maximize area, and you have a 4 sides, it will be as square as possible. But it's not. That's not true if you only have 3 sides. Don't listen to that.
Technically has 4
Okay.
sides.
Yeah, but we're not using resources for this 4th side, right? So if you have 4 sides, you want it to be a square because that's going to maximize the area. But if you're only using resources for 3 sides, it's not a square anymore.
Would it be a trapezoid then?
No.
What?
It still has to be a rectangular thing, but what? Okay, I don't want to. Okay, whatever.
Getting all out of breath now.
Let's say you have
Off on a tangent.
Yeah, sure. Let's say you have 100 feet of fence, right? Okay. And I have 100 feet of fence to use for the perimeter, right? I could make this fence line 1 by 49 by 1 by 49, because that has a perimeter of that, right? But what's the area of that thing?
49.
49. Versus doing something that is as square as possible, which would be 25 by 25 by 25 by 25, right? If I make it a perfect square, the area of that is 625. True?
True.
Which one has the bigger area? The one that's a square. So, Brady over here is saying, okay, if you have 340, you just want to divide it by 3 and making all 3 of these sides the same, right? That's true if you are encompassing all 4 sides. You want to make it as square as possible. But if you're only using your resources for 3 sides, it's not necessarily going to be a square.
You want it longer?
You want it to be, I think, longer. I think you want your y to be slightly longer than your x. Yeah, I don't remember what the ratio is, if there's a shortcut to it. So we're going to figure it out. So how do I use these 2 equations to figure out the maximum?
You don't.
So like a
Sure, divide by 4.
I need to figure out how to use one equation to plug into the other one, right? Okay. I want to, let's take this top equation. Whoop. Let's take this top equation and let's solve for y, shall we? Let's do it. If we solve for y, I'm going to bump the 2x over. So I have y equals negative 2x plus 340, right? Okay, shh, listen. Shh, shh. Okay, now I'm going to take this guy and I'm going to shove him in there. Okay? So I have x times negative 2x plus 340. And I'm going to shove that in there, right? Okay? So I want to maximize that. This is still finding the area, right? Area is equal to that thing. Okay, let's distribute the x through. So I've got negative 2x squared plus 340x. Okay? And I'm trying to maximize that. That's the area, right? Okay? What does this thing look like if I graph him?
Where?
A downwards parabola, right? Where did I
You
what?
have to find the vertex.
Yeah, so I want to find the maximum. Maximum is vertex, right? How do I find the vertex with this thing?
That thing.
Oh.
Negative b over 2a, right? Okay, so what is b here?
340.
340. So negative 340 over 2 times negative 2. So basically the negatives are going to cancel. So 340 divided by 4.
Divide by 4. Okay. So it's 85.
Is it 85?
Yeah.
Yeah, 85. Okay, 85 comma something, right? Okay, so that's what the x coordinate is, right? Of the vertex. Okay, so hold on. X would be 85, right? 85, 85, but what's y going to be?
170.
170, right? Yeah, yeah.
That's right. Jacob
1 to 2,
wasn't
1 to
fast.
2 to 1 is what it was. Yeah. Yeah.
Jacob wasn't fast.
Is it? Is it always 1 to 2 to 1 then? Probably.
What it was when AI Sabrina taught me this.
When what?
When AI Sabrina taught me this.
Interesting. Okay. All right. So just really quick, how do I know that this is 170? By the way, you guys said that. If I take 85, I can plug it in wherever. So like 85 goes in here, right? And then add the 340, so I can plug that in and solve for y. So you're just plugging it into another equation to solve for the y variable, right?
So
Okay.
if you would have made it a square, what would it have looked like?
It wouldn't be maximizing the area.
The line is not. What's the answer? Just It would not 85, be 170.
What?
85, 170.
Then okay, so determine the dimensions. The dimensions would be 85 by 170, and then find that maximum area. So what would the area be? If you do 85 by 170.
14,450.
14,450. Okay, real quick.
If you would have made it a square, its area would have been 7,220.
Okay, but hold on. Did you divide by 3? Did you take 340 divided by 3? Because you only have 3 sides, right? But that would make them a square, right? If you took 340 divided by 3, because we're only using 3 sides. That would be 113.3-ish.
Yeah.
Yeah. Okay. So it would be 113.3 times 113.3. What is that going to be?
12,844.4.
So slightly smaller than this, right? If you would have made him a perfect square. Does that make sense?
Can we draw?
Can we work on
it
homework?
out?
What?
No.
Just wait. Just wait. All right. Do you see why that is? Okay. If you're only using resources for 3 sides, it's no longer a square that you want to maximize area. Okay. Last thing. You need your calculator.
I'm not using one. Only my brain.
Use a regression to find the quadratic function to model this data.
Oh, you have to have.
Yep.
Graphing calculator.
You have to use your graphing calculator. Do you have your graphing calculator?
Graphing calculator.
Graphing calculator. Graphing calculator.
I will calculate.
Does Desmos give you a spit out an equation though?
No.
It will if I make it. Or it will if I pay.
If you ask, you kind of know probably and know how to do it.
I don't. If you know how to do it, I know. I think it will, but I don't know what the shortcuts are. So use your calculator. Okay. Do you know where you go? We've done this before. We've done linear regression. Now we're doing quadratic regression. So the first thing you're going to do is you are going to make sure your stat plot is on. So number one, stat plot on. Do you know where stat plot is? Stat plot. Go to stat plot. So it's second y equals. Second y equals.
On or off?
Okay. You want to make sure your plot is turned on.
Second one?
All of them?
The first one. The first one.
Okay, that's done.
The first one's on. Okay. Number two, you're going to enter your data. So you're going to go stat. Hit the stat button, and you're going to go edit. And it's going to give you your XY table. So it has like L1, L2, blah, blah, blah. Like list all those out, right? Okay. Now you're going to type these into your L1 and you're going to type these into your L2.
Wait, how do you get there? What?
Stat edit.
Where do
Or
you get-
stat enter, basically.
Where is this?
Hit the stat button. Stat button is like
Stat,
on the right at the top.
edit, and then you're gonna put L1,
Okay. Who doesn't know where you are?
L5.
I'll come help you.
Stat, edit. Okay.
Stat edit.
Whoa, how do I clear, like, the rest?
Go up to the top. Go up to L1. Like
Mine
toggle
doesn't
up to
have
L1
L1.
and hit clear enter.
Mine only has L5 and L6.
Ooh. It doesn't? Okay. We'll fix it here in a bit. That's
Okay.
fine. I can reset your calculator and make you have an L1, but we'll deal with that here in a second.
But I can just put on L5 and L6.
Yeah, when you do your regression, yep. Okay, stat edit, enter data. Enter data. Is everybody where we're at? Right. Does anybody not know where we're at? I will come help you.
So.
Whoa.
98.6. Significant number.
Now what do I push after that?
To graph.
0.3. Graph? Just graph?
Hold on. Nope. We're going to change the window.
0.3. 98.6. Oh, you have to change it too.
The x's. What's our lowest x? Okay, so change your window, 25 to 100.
Now graph?
Then graph.
It looks like a...
Does it look like a parabola? Up or down?
Up, down, down.
Down, a downwards parabola?
It's called a
Okay,
regression, I
so
switched
step 4. To equation.
0 to 50?
Whoop.
now. Yes.
0 to 50 and 25 to 100 for y. It doesn't matter as long as you're outside of like what the numbers are. Like you wouldn't be able to go negative 10 to 10 and you'd only see like no points.
So y min is
Where's the equation?
Wait, how do I hit
Okay?
graph?
There, invalid dimensions.
Where's the equation?
You gotta hit window.
All right, did it do that when you started a graph?
X
Yeah.
is
Okay, stat, edit.
Equation.
Mine looks like a whopping nothing.
mine looks like a bunch of points
Okay.
on the graph.
Well,
Because the one that it's plotting is L1 and L2,
No, L5 and L6.
not L5 and L6.
Well, how am I supposed to know that?
man.
Well, you gotta make it do that. There you go.
What?
All right, to do the equation, do you know how to make it spit out an equation for you? Yeah? To make the equation, go stat. And go over to calc. And go down to, what are we going down to?
tell me mine is broken.
Quad reg.
Quad reg.
Enter.
Okay? Use regression to find a quadratic function that models the data around the coefficients to 3 decimal places. So,
There we go.
y equals. Okay, you should have like ax squared plus bx plus c. Give me what a is. 3 decimal places.
Point.
Negative?
Hold on.
.173.
Negative
Yes. Negative
0.173 x squared. Okay?
x squared. B is 8.
Plus
8.12.
8.312 x. C is
Negative 1.385.
No.
Yes, it is.
Sure.
okay, sure.
1.386.
86.
1.38.
5.7, so round.
6. Okay, there is your equation. Yes, yes. Use the model to determine the time at which it is the greatest. So what are we looking for?
Vertex.
The vertex. How do I do that?
Negative.
Negative b over 2a. And we're looking for the time. So we're looking for the x coordinate, right? Negative b over 2a. All right, here we go. Negative b. This is gross. Over 2 times negative 0.173. Okay? Do that. If you're going to do that, do this instead. Times If you're going to enter it all in one shot, do that. Okay, it should be a positive number. What do you got? Round to the nearest hour.
Oh.
Okay, how many hours does it take for this thing to, what are we talking about? Are we talking about, like, bacteria? There you go.
0.72.
I don't think so.
Like, I had 24. Yeah,
24?
Ellis, I got 24 also.
24 also?
I got 24.
Okay. So, 24 hours is the maximum number of bacteria. Why is it decrease after that?
Because they die.
Because they die and they run out of resources in whatever it's infecting, like the bread or whatever it is, right?
Yeah.
Okay. Now, what is the maximum population? What does that mean?
Whatever, plug in,
Y coordinate.
put 24.
Plug the 24. Was it 24 exactly or was it 24?
24.023.
Okay, let's just plug in 24. So, plug 24 into here and to there, right? Okay. And you'll get your maximum population. And then we got to do one more thing. Round to the nearest 100.
Clear.
Woo.
Negative .173 and 20.
So it'd be like 600.
Like 6. Trevin, Dylan, Kellen,
No.
Ryler, Brady, Colin, Kate,
Dylan.
Bryce,
Dylan.
What?
I
I don't remember if we got a medium.
Okay, but look at your table.
Whoa.
Woo.
98.5.
But you got a medium.
Also, hold up really quick. If we know it's at 24 hours, look at the table.
I got.
24 hours lives right here.
Can you
Hold on. Hold on.
tell me why a calculator's wrong?
98.45.
My calculator says 50.
I got 98.45.
You about had brown hands there.
Come on.
What on earth is happening?
I don't know. He was doing so well until today.
Until he
Assaulted me.
started stick-hitting.
What?
Looking for a signal. My device is on and it's plugged in to HDMI 2.
Swagger. That looks pretty swagger, Dylan.
Okay, we're gonna try it again.
Wait, Macy, what did we get?
You like it?
98.44.
What?
Do you like it?
Come on.
It looks
Says round to
What
the
is the
nearest
matter with you? There we go. Okay, so 24 hours lives between these two, right? And so my number should be somewhere between 96 and 98. What do you get?
98.5.
98.5. Okay,
actually, that's not right, Macy.
98.5. But that means in thousands. So if we convert that to thousands, I'm going to move my decimal. How many places?
It doesn't matter.
3 places, right? So it
25
is
would be the highest.
98,500. Do you see it? Like this, these numbers don't actually mean 37.3. That means that many thousand, right?
98.6 is the
Touch
highest
me.
number.
Look at 25. It's higher than
Oh. Okay, but you know why, though, probably?
Because we didn't round.
Because we rounded this 24, so it's probably like a little bit different.
6.7.
There you go. Okay, there's that. Beautiful? Good?
98.6.
All right, that is all. Okay, do those last 3 problems and we're done. Goodbye, Owen.
I'll do that.